Jim Kunkel here. Make sure that you subscribe to my channel and set the notification bell to all so that you won't miss any of my new content. Welcome to another episode from the Carboline Technical Series. Today's topic will be passive fire protection for commercial and petrochemical, and my guest today will be Stuart Bradbury, who is a product line manager from Carboline. I hope you enjoy this episode. Hey Stuart, welcome to Global Topic.
Hey, good morning, Jim. Thanks for having me.
Hey, if you could do me a favor, and also for the viewers, if you could go through a little bit about your background and your roles and responsibility at Carboline.
Yeah, sure. I'm a product line manager with Carboline. I've been with the company a little over 4 years now, and directly involved in the passive fire protection industry for roughly 17 years, in various roles. Within Carboline, I'm responsible for the strategic market and product development of our global fireproofing product line, in addition to our Thermaline, high temperature and Carbotherm insulative performance coatings.
So, when we talk about, passive fire protection, there are going to be viewers who have a limited knowledge or some might have no knowledge whatsoever. Could you go a little bit and do a little bit of an overview regarding passive fire protection?
Yeah, sure. I mean, it's a great question, and something that comes up quite a lot of the time. What is the difference between active and passive fire protection systems? Passive fire protection materials or system components are those that require no manual intervention in order for them to perform as intended or when called upon. They're often built into the building structure and are absolutely a fundamental component of the overall fire protection strategy. I suppose in the context of today's global topic, the term passive fire protection can also be referred to as fireproofing. Sometimes they're used interchangeably. And that in a sense applies to both spray applied fire resistant materials and intumescent fire resistant materials used in commercial or petrochemical market segments. Ultimately, the goal of any PFP system is to protect assets, maintain points of egress for personnel, prevent structural collapse, and ultimately save lives.
So, for this episode, we were going to talk about the aspects of the commercial and then obviously petrochemical. So very different industries, different levels of protection. Could you maybe go a little bit and provide some detail related to, what's the differences for what a commercial setting would want versus a petrochemical when it comes to PFP?
Yeah, absolutely. I think as it relates directly to steel fire protection, the commercial market, for the most part, is split into two primary protection methods, those being spray applied cementitious materials and intumescent paint materials. PFP products in the commercial market are subject to what would be considered cellulosic fire. So these are fires that are characterized by the burning of cellulosic products such as wood, furnishings, or paper. Test standards such as UL 263 or ASTME 119, depending on where you are in the world, there are functional equivalents such as BS 47621, ISO 834, or the EN 3081 series. They essentially evaluate the performance of a building construction and material, and these standards essentially simulate a fire that would occur in a commercial building such as an office space, high-rise construction, hospital or school. They have a relatively slow rate of temperature rise, which reaches 538 degrees Celsius within 5 minutes of the test commencement, and that will gradually increase to 1,093 degrees Celsius over the duration of 4 hours. So that's considered a standard time temperature curve. In contrast to cellulosic fires, the petrochemical market can be categorized by hydrocarbon fires, And these are more turbulent than a cellulosic fire. A pool fire would be characterized by burning hydrocarbon fuel, typically from an oil deposit or an ignited gas cloud. And test standards such as UL 1709 evaluate the thermal resistance of a protective material and its ability to withstand fire exposure. This is more of a rapid rise time temperature curve and generates an environment where that total heat flux that's roughly 200 kilowatts per square meter, and an average temperature within the furnace will reach 1,093 degrees C within 5 minutes of the test commencement, and maintain that for the duration of 4 hours or longer.
So typically, when people really start looking at, fire protection, we have catastrophic events happen. A petrochemical plant explodes, and obviously, the idea is to contain or to control the burn when it comes to that. And then obviously, years back we had the UK Tower, where a high-rise complex of apartments, caught on fire and everything like that. When it comes to global requirements, is there consistency globally, or is it a very inconsistent industry?
I think for the most part it's getting better. I think each country and region adopts a different model code, which sometimes adds confusion as to the requirements of rating a structural member, for argument's sake. Here in the US, we follow the IBC, which is clear on building type and occupancy, and the integrity ratings required for primary or secondary members. And different model codes do exist throughout the world. I think as an industry, it needs to be a little bit more regulated in terms of inspection, perhaps. And that is certainly something that will be drawn out of the recent Grenfell tragedy, and numerous petrochemical fires that have occurred in recent years.
Because when you really look at it, the preparation, the application process is very critical. But to your point, the inspection needs to be consistent, and and across the board, it has to follow certain types of standards, and also for testing and everything like that. You had mentioned earlier some elements of testing when it comes to commercial and architectural. Are there any particular tests that are involved related to products to really help educate architects, engineers, and building owners?
Yeah, as it relates to the commercial sector, as I mentioned, UL 263 and ASTM E119 here in North America, or CAN-UL CS 101 north of the border in Canada, are the standard test requirements for passive fire protection materials. They define the test standard into floor ceiling assemblies. They'll look at restrained and unrestrained beam ratings, columns that are typically unloaded, and they're all exposed to that standard time temperature curve at varying thicknesses. The thickness of a material often depends on the section factor of the steel, and its thermal mass, which really dictates the temperature rise within a specific member. So typically the way in which we characterize section factor here in the US is through a W/D calculation, which is it's a heated perimeter that's exposed to a cross-sectional area that's exposed to fire. And the lower the W/D number, typically the greater the thickness material required, and the higher the W/D number, the less material that's required.
Very interesting. So when it comes to the commercial and architectural sector, and then obviously the petrochemical side, is there a big difference between products, or is it relatively the same?
I think there's a fundamental difference between the chemistry within the products, but the two primary protection methods of spray apply fire resistant materials and intumescent materials fall within both market sectors. So for argument's sake, if you were looking at a commercial project and we were looking at, say, using one of our Southwest fireproofing materials, they are relatively low density materials, low, medium, and high, anywhere between 15, 22 pound and 40 pound in place densities. And they can be either gypsum based or Portland cement based in composition. But in comparison, when you look at a petrochemical project where you have a UL 1709 standard, typically most spray applied fire resistant materials will have an in-place density of between 50 and 55 pound per cubic foot. And that really adds some durability to the product because of its end use environment. So that's a real difference between the two mechanisms there.
So, Carboline obviously is a major supplier of PFP products and solutions. What products does Carboline offer the industry?
As a global manufacturer of passive fire protection products, we're actually, I'm not going to say the only one, but we're one of possibly two, maybe three, that has both spray apply fire resistant materials and intumescent materials for both market segments, so both hydrocarbon and petrochemical. From a commercial architectural perspective, we have our Southwest fireproofing product line, and again that ranges from low, medium, and high density materials. We have a real comprehensive intumescent thin film product line, which has waterborne, solvent-based and epoxy-based resin systems. Our Firefilm 3 and 4 products are waterborne technologies, and their end use is interior environments. They have tremendous finish characteristics. In contrast, our Thermosorb VOC and 263 products are solvent-based, and very much like Firefilm, their end use is also interior environments. But unlike waterborne products, they have a wider application tolerance, which makes them a product of choice within that commercial sector. And we also have Thermalag E100, which is a 2-component epoxy. It's inherently flexible, has great thickness ratings, and is suitable for both field and shop applications. And it's exterior rated.
So about 3 years ago, I had the opportunity when I was at the Carboline headquarters to actually observe and witness a fire test of products that Carboline produces. And I also had a chance to take a tour of the laboratory and a lot of the science that goes behind the products that you guys produce and offer out into the market. Is there anything that is new coming out from Carboline in this series? Yes,
absolutely. First and foremost, I'm glad you managed to take that tour, and we'll certainly be glad to have you back. In this past year, we've actually opened our Carboline Fire Research Center, which is a full-scale test facility, which will at some point operate under both UL and Intertek satellite programs. So that will enable us to provide speed to market for new product development and to update existing products also. In terms of new product development, we launched Pryocrete 341 in July of this year. Pryocrete 341 is a Portland cement-based fireproofing material that provides hydrocarbon fire, jet fire, and cryogenic spill protection for onshore structural steel assets. For all the subscribers there, Pryocrete is a tried and tested and proven solution as a product brand. It's arguably the product of choice and has been providing asset protection for over 40 years since its inception into the market. So this is the next in that line of series. It's a truly unique product. It was developed for both shop and field application. It's easy to spray or trowel. The physical properties with this product are far superior than any other competitive product on the market, and its durability is unrivaled. The product itself develops early hardness, which rapidly increases shop throughput. To provide some context there, we're looking at a 50% reduction in throughput compared to current cementitious products. The application properties, so the build and the sag resistance, along with extended working time, will make this product a real big hit with applicators, I'm sure.
So, related to PFP technical support, Carboline has online live technical support. The resources that you guys, I had a chance to take a look. A lot of great resources for architects, engineers, owners, and other entities out there. Also, the support you supply to the contractors as well. What type of training related to products do you do for contractors, craft workers, and things like that?
Yeah, I think training is of paramount importance, given the end use of the products in which we manufacture and supply. So we at Carboline, we hold multiple training schools throughout the year. This year has been that exception due to that virus that seems to be going around that people are talking about. We hold commercial and petrochemical fireproofing schools, where we look at theoretical content. We give students and attendees a look at why we use passive fire protection. We look at limiting temperature of steel, and then we look at specific products, their end uses, what they've been tested to in terms of industry standard. And then we'll take that theoretical knowledge, and then we'll go and do some hands-on practical application with all of our product lines, so we can assess the skill set and the level of those in attendance.
Yeah, Stuart, what a great conversation we're having on this topic. Closing out this episode regarding passive fire protection, is there anything that we did not talk about that you would want to leave with the viewers?
I suppose because we've covered a very high level overview and introduction into passive fire protection. I suppose it's important for viewers to understand why we apply fireproofing materials as opposed to structural steel. It will add additional context to the materials and the test standards that we spoke of. So I suppose it's important for everyone to understand that materials will weaken with an increase in temperature, and steel is no exception to that. So carbon steel loss, dependent on the grade, is generally accepted to begin around 300 degrees Celsius and increases rapidly thereafter. So by 590 degrees Celsius, steel will retain only 50% of its yield strength and 45% of its stiffness, which negatively affects its ability to support or carry a load. And the application of an intumescent paint or cementitious material would provide short-term thermal protection by insulating those steel sections through either char development or steam layer, dependent on the material type, which slows the temperature rise in the underlying steel section for a given period of resistance. So I think it's important to understand that within 5 minutes of either a cellulosic fire and certainly a hydrocarbon fire, the temperature rise is almost at the point where steel would lose its yield strength in 5 minutes. So I think that's key for your subscribers to understand.
Definitely very important. And I will put links in the video description related to not only the products, but also to the fireproofing page on the carboline.com website. Stuart, I greatly appreciate this opportunity to have this conversation with you today.
Oh, thanks, Jim. I appreciate you taking the time out of your day. I love the channel and hope you and all your viewers have a Merry Christmas and enjoy the holidays.
The same to you. Hey, have a great day.
Yeah, you too. Thanks, Jim.
So, Joe, for the lay person who's watching this episode who might only think that corrosion engineering